Okay, good. Now we stop it for the moment of inertia. In this case, the same calculation like before. We have something like this formulation: mass product u dot dot plus ku is equal to k pt blah 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 and so on. Okay. In this case, we have no mass. In the second case, we have inertia. And instead of displacement or acceleration, we have an angular acceleration and angular speed, okay? Angular speed is equal to omega. I think it's maybe known for you. We will discuss about angular speed later, okay? So, the inertial moment of the disk, circular disk, is equal to mr squared divided by 2. I already told you. And here we have C is in this, sorry, what is the C? Center of mass.
Жесткость переключения стержня.
Yes, maybe, yes. Yes, C is the K. Okay? K. Spring stiffness. We know spring stiffness, we discussed it in previous cases as a force K. Here is a K. If we have spring stiffness, it is a K. C is in the rotational case, torsional case, okay? You understand? In this case K, in this case is C, is rotational, okay? Stiffness of, huh? Stiffness of, spring stiffness. Пружинана накасы. Stiffness of. Бекерлиги değil mi? Бекерлиги дегенді sen istiyor musun? Пружинаның бекерлиги. Осы жесткость, пружинаның жесткость. A torsional spring'de namına C болады. If we look in previous slide, K was equal to, for this type of spring, 24 Young modulus product inertia divided by L's cube and blah blah blah. In the next case, for the torsional cases, C instead of K, we have a torsional case. This is equal to C, P product disk, degree is 4, product G, and divided by 32L. For different type of disk and different type of this type of sectional torsional spring, we have different type of C, okay? If this is quadratic, not circular, this coefficient is going to change, okay? Agar mana bu narsa dumalog'imiz to'rtburchak bo'ladigan bo'lsa, mana bu C ni qiymati o'zgaradi, boshqacha bo'ladi. Tushunadingmi? So, we have the same formulation for the comparing. Can I clean it? Yes? Kecha ko'pchilik bordi, yana bu yerda qizarib oladi. Qattiq siqib qo'yadimi deyman, bu yo'q.
Просто через ost geçmesi gerekiyor. Başka sıkması gerekiyor.
Yo'q, sig'masga joy topib beraman sizga, boshqa parta bor. Yana bor, ha? Qayerda ko'p narsa. Ispravda. In previous case, mu dot dot plus ku was equal to pt. Yes. In our new case, j theta dot dot plus spring stiffness theta is equal to mt. Okay. Mt is some rotational movement, external movement. Okay, this one. Let me say something like a force. Okay. In this case, the unit of this one is not equal to the force, like not Newton. Its unit is almost the same with the J. Okay. If you calculate the unit of J, here, okay, mass product meter square. Okay. Mass meter square. This is also the same unit. This one also the same unit. Here, if you look, this also should be the same. G was a gravitational, I don't remember, I'm sorry. I forgot this course because 2 years ago I gave this lesson. This way, sometimes we also forget, okay? This one and this one units should be the same. We will identify later, okay? Never mind. It's so,
модуль упругости сдвига. Модуль сдвига.
Модуль сдвига?
Для стали примерно 0,4, например.
Е?
Ну они,
Е?
они подобные, да. Модуль сдвига. Тот модуль упругости, который
Да,
это модуль сдвига.
все помню.
Это то же самое, только
Это зависит на это. Young Modus. Это на это похоже.
это именно это и есть, только Young Modulus это у нас сигма эпсилон, а это у нас получится гамма и мера, ну, угловая.
Да, угловая.
И это будет на этом графике тангенс угла наклона в точке угла.
Yes. It is also the same thing. For the K it was 24. Let me write I here and E divided by L3, yes. This was Young models of elasticity. In our case, this is also the same thing, yes. This is also stiffness of the spring for rotational case. That's why this is also modulus of elasticity. D4 G divided by 32 L. Okay. What?
Потом я дорисую.
Да. So, next case, we have a moment of inertia created by just fictitious inertial forces for any point of our object. For instance, if we cut some place of our disk, something like this, yes, or we have some stick, how we can calculate inertial force for this part of this disk, okay? We cannot calculate wholly, that's why something like an integral or differential, did you remember? We have such kind of thing. We will only some small particles, we can cut them and then we can add them together, okay? And then we can sum of all these forces for the x, and then we can take totally this inertial moment product theta dot dot. So, and then we took some integral blah blah blah, and for this case we took for this stick, let me say, this stick we took J is equal to ml squared divided by 3. Okay? If we have a disk, this will become like this. If we have rectangular shape, it is also going to change. If you have triangular shape, if you have any kind of different shape, this formulation will be going to change. For any other type of shape, this moment of inertia will be different. Okay? For this case, this one is equal to like this. Okay? So you can find this is from the internet for any other type of shape, and you can put some numbers if you want to calculate, and then from this shape you can find the inertia, moment of inertia, and you can make some calculations. Okay? Everything is derived from something like this. Rho is something like the density of mass separation, where is located our mass, blah 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 blah. From this integral you can identify how much was for this type of case, how much was for this type of case. This is not for you. If you are working with scientific work, maybe it is okay for you. You can derive, you need some formulation, from formulation you can identify everything. Okay? That's why for our case, it's okay if you find from the internet, well known some values and put it here, okay? So next case, free vibration. In our case, in free vibration case, we have no any external force. Equation of motion will be equal to mass product acceleration plus k product u is equal to 0. It's in static equilibrium condition. Okay. And this is E. E is the number. What was it? 2.7 something like this, mathematical number. If you remember your higher mathematics course, yes, in bachelor degree, I think you have already studied about this one. It is this, And complex conjugate numbers, also we are going to discuss this. This is complex number, it's J. Or we discuss it in our mathematics course, like something like I. I squared is equal to minus 1. You do remember? I squared was equal to minus 1. This is a complex number. It is, in fact, it is impossible to identify such kind of number. It's impossible, but that's why this is a complex number. You cannot make something like a square of something. It's impossible to be negative number. Yes? Yes or no? Shunday. Birorta sonning kvadrati hech qachon manfiy son chiqmaydi. O'sha manfiy chiqadigan son bu o'sha kompleks son hisoblanadi. Tushunarlimi? Bizni sistemamizni endi kompleks sistemaga o'tkazamiz va kompleks sistemadan o'sha sinusoidalni, kosinusoidalni signallarni biz navolarimiz bilan ajratib olamiz. Tushunarlimi? Siz tushunganingiz Okay. So instead of u dot dot and u, I will put some complex number. Okay. If in my case ut is equal to g1 e j omega n t plus g2 blah 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 blah. This is a real case. This is a imaginary side. Okay. For the complex number, we have two sides. One real side. Second one is imaginary side. So we will add both of them, and then from this, if we suppose that G1 is equal to G star, so we can identify some coefficient E, J phi. This is a phi is a phase shift of our signal. Okay, maybe something is confused here. But if we discuss, if you make some tests, you can identify or you can understand what is the phase shift, what is the real just movement of our object and so on, okay? This is not so difficult in actually, but with formulation it seems very difficult, okay? As formula qiyin ko'rinyapti, lekin o'zi aslida qiyin narsa emas bu. Phase shift is something like this. One of the best example I will show you. If I have a building is moving like this, yes, like this, it has no any phase shift. If I am trying to move some part, okay, maybe this is not so convenient for example. If you move our building something like this, yes, phase shift occurs when you have another buckling effect occurs something like this, okay? In this case, phase shift means the same signal is going to repeat, but with some lead or with some lead, okay? Lead means it's a leadering. It's going forward or going backward from the input signal, okay? Kirish signalimizdan chiqish signalimiz farq qilsa, ortda qolib ketsa yoki oldinlab ketsa, o'sha leading yoki lagging bo'ladi. O'sha leading bo'ladigan bo'lsa yoki lagging bo'ladigan bo'lsa, o'sha fazada o'zgarish bo'ladi. Fazada shift bo'ladi. O'sha phase shift'i mana shu phi bilan belgilanadi. Tushuntira oldimmi? Omega n bu natural frequency of system. Phi is the phase shift, and this totally over this system is, for instance, our system is equal to ut is a displacement. Our system's displacement is equal to something like this. We can write it something like this way: c cosine omega n t minus phi, or a cosine omega t plus b sine omega t. Okay? You can separate it like this. If you separate this formulation, you can achieve this one. Okay? This is trigonometry course from higher mathematics. Bachelor of Mathematics. Okay, for the case of mass spring, we have a natural circular frequency is equal to omega n is equal to square root of k divided by n. Okay? This is in radians seconds. Unit is radian per second. Or we can find the natural frequency in hertz also. For the building, we have to identify exactly what natural frequency building has. Or we know the period. What is the period and natural frequency? Do you know what is the period and what is the natural frequency? I think you have no idea. Yes, you have finished. I saw from your eyes. Fatality or brutality, yes. Come on! Have you ever played the Mortal Kombat? Yes. Okay. Maybe animal, I don't know. Okay. F is equal to 1 over T. And also we have F frequency is equal to omega 2 pi omega n. I didn't make a mistake. No, yes, I think I made a mistake. And then I write different way. It was also existing in my second slides. Or if we find F, if we equal to 2 pi divided by omega n. Or another way I can write it something like this. Okay. E is equal to 1 yes, 2 pi divided by omega n. Yes? Yes. This is a period. This is the natural frequency. This is natural circular frequency. Okay? Actually, F and omega is depend on with this formulation. What is this one? This both of them the same. I found from here F, or you can find from here omega n. Okay? Okay? Okay, one of the sample I will show you what is the natural frequency. Okay, this is too hard.
What is T? T is
T is a period.
period. Okay.
Yes. This is not small t, this is a big T, okay? Big T. If we put here initial conditions, U0, yes. Yes, from the physics course, displacement and the speed formulation depends. That's this one. Here we have initial condition of displacement. This is a displacement which is depending on the speed in this case. Okay? This is a displacement. This is initial condition. Initially it was not 0, maybe 0 or 1. And this is a coefficient A. For the second case, E omega n is equal to, if we try to derivate this one, you will find B omega n, and also, it should be cosine, why it's sine? Okay, yes. This is a velocity in our case, okay? From velocity, if I divide from velocity, unit of velocity, yes, what? Meters per second, yes? This is radian per second. If I divide meter per second, radian is nothing, okay? Just second itself, radian is a no unit, okay? If I divide meter per second divided by again 1 over second, it will become meter, okay? Anyways, the unit of this one, unit of this one, and this one is the same, okay? Actually. The formulation of, if you remember from your physics course, formulation of displacement, you remember? It was also depend on speed, acceleration, and some initial displacement, yes? This is another way to how to write this formulation, okay? Do you understand? Yes? No? Okay. No? Here we have initial condition. Initially it was not zero. And initially it has some speed, okay, our system. That's why we identify our system displacement with some initial displacement and initial speed. So, okay.
Why is it multiplied on cosinus? I don't understand. Cosinus and sinus.
Because our motion
Direction,
is
yeah?
sine wave, okay? It is not any linear motion. It is a sine motion. If I do like this, look, it is sine wave, yes? Sine and cosine wave. That's why it is multiplied cosine and sine, okay? The system cosine wavely just moving, like a cosine. It's, of course, it's stopping. We think that it's never stops, something like this. Okay? If there's no any friction, blah, 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 it never stops. But we have a friction here. We will also add for this formulation some friction coefficient and so on and so on later, okay? It is just only case of simple case, okay? Simple, not complicated case, okay? If we have complicated case, we have to add some friction coefficient, damping coefficient, blah, 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 and it will be very big for me. For the now, the small formula is okay, okay? Later we will add some, okay? You cannot accept it, your stomach, otherwise, okay? U0, for instance, if I move object from 0 point to here, I have maybe 5 millimeters, 5 centimeters or 10 centimeters. This is a displacement, okay? And if I move this one with my finger like this, with some speed, okay, it will be U0 dot. Okay? Did you understand? No?
Acceleration.
No, this is its velocity. This is initial velocity I am adding, okay, our system. If I am adding with some initial velocity, no, I don't have any initial velocity. Only U0 itself, okay? If U0 dot with some velocity, okay, this system will be something like this. The total of our system, in this case, depend on initial condition of U dot and U0 itself. U0 dot and U0, okay? Now it's a little bit clear.
All this formula about displacement.
Yes, ut is a displacement. All this formulation is about displacement. Okay, now we came at that point which you asked. This is the initial displacement which I started to move on my object, and this is the initial speed. Okay? Do you understand? Now I can derive the coefficient C is equal to U0 dot dot. This is a complex algebra. From complex algebra, you can identify what is the C, what is the A. This is a differential equations. Yes? If I remember.
Ну, только наоборот интегрировано.
Yes, it's integrated, but differential equations, from differential equations you can find as kind of course from the mathematics. This is a very famous thing, not only in our subject, but it is used in most cases. Okay. Yes, this is a C coefficient is exist. Every integration you will add some coefficient. And what is the cosine? What is the sine? Everything is exist here. Okay. Sorry. Just this is the initial condition of speed. This is the initial condition of the displacement. This is C is the amplitude. Okay. C is, let me say, yes, this is amplitude. This is not the RMS value. Root means square value. Okay. Okay. The period in our case is how much time do I need to start from here to come again this point. Okay? This is a called period. Clear? Period bu mana bu joydan bu joyga qaytib kelishimga ketadigan vaqt. И натуральный частота Герц bu 1 sekund ichida necha marta siklin borib kelishi. O'sha narsa natural chastota hisoblanadi. Tushunarlimi? Tushunarlimi? Telefoningizni so'ragan.
O'zbekcha tarjimasini qilyapman. Buni olib o'zbekchasi. Tushunmadingizmi?
Period birligi sekund bo'ladi. The unit of the period is second. The unit of the natural frequency is in hertz. Okay? Clear? Okay. Demek, let me explain in Uzbek. Demek, tochkamiz 1 sekundda qancha sikllar soni bu bizda natural frequency bo'ladi. 1 sekundda o'sha tebranishlar soni natural frequency bo'ladi. Keyin bunisi esa o'sha bitta tebranishga borib kelishga ketadigan vaqtim period bo'ladi. Tushundingmi? Natural frequency bilan period bir-biriga bog'liq kattalik. Fn teng 1 taqsim period. Natural frequency 1 taqsim periodga teng. Tushundingmi? Natural frequency is equal to 1 over period. Okay? It's almost the same thing. If you look at formulation, yes, the same. Oh, I'm sorry, I made a mistake. Here it should be yes. Okay. Sorry. Okay, this is radian. This is the second. Okay. This should be, this one is true, but F, if you wrote F, this one should be inverse. I'm sorry. Okay. Okay, I also made a mistake sometimes. I'm very sorry. Because it should be inverse, not the same. Okay. This is a difference between natural frequency and natural period. For the buildings, we have to identify what is the natural frequency, that's what is the natural period, using the accelerometer, okay? Accelerometer or velocity meter. From this type of equipment, we can identify buildings' natural parameters. If you look, guys, this natural frequency is dependent on what? Here? Stiffness and mass, yes? Stiffness is, for instance, in your case, building has a column, yes? Column has a stiffness, and building has a slabs, yes? Ground slabs, first floor, second floor, blah, blah, blah. This slabs has some mass, okay? So it means that natural frequency of the building is depend on the stiffness of the building, the hardness of the column, let me say, and the mass of the building, okay? If the mass is very high, natural frequency will be lower. If mass is less, natural frequency will be higher. Okay? It means that if you have a lighter building, natural frequency of building will be higher. Okay? It will be hard. If the building mass is very heavy, it moves very slowly. Okay? Very slowly. It means that building has a low natural frequency, maybe it's not so good. But higher buildings, higher stale buildings has a lower natural frequency, okay? And they have a long period. For instance, maybe Tashkent TV tower has a period about 5 seconds or 10 seconds, around like this, okay? Do you understand? If you have some wind or earthquake occurs, in 10 seconds from this side to this side, it will goes and back. It needs 10 seconds because it's very tall, okay? For instance, if you have a 2-floor house, maybe its natural frequency is 5 Hz. If you give 5 Hz signal, so your building maybe makes or it can accept its own natural frequency, maybe its amplitude is going to increase, okay? So main purpose of to analyze the building, to find some circular and natural frequencies and some periods, okay? Okay, good. This is, I have explained already. Okay. Energy undamped and free vibration. Now in our cases, we have two types of energies exist. One is kinetic energy. Second one is strain energy, or another case we can say it is potential energy. Do you know what is the difference between the potential energy and the kinetic energy? Yes? Potential energy, if I tighten the spring with some force, spring is going to backward, yes, itself mass or itself inertia, to return your every object to initial condition. This is called potential energy. And the second one is K, is depend on the speed. If I am dropping one object from the top, this object, if I am dropping this object from the here to here, if I am keeping it like this, it has a potential energy. Okay? When it starts moving, it has a kinetic energy. Okay? If objects has some energy, which is a gravitational energy in our case, yes, this is called potential energy. If this object is moving already, there's gravitational energy also attracting it to the downside, but it's in moving condition. So it has some kinetic energy, okay? So this is a kinetic energy. It's energy which has some moving place. This is a moving speed, velocity, I'm sorry. Kinetic energy is equal to 1/2 m u dot t square. Just maybe from your mathematics course or from your course of school, it will be something like this: 1/2 mv square. Already you know this one, yes? Yes. And next one is strain energy. This is the same as potential energy. Is equal to E S over, ES is equal to 1/2 K U T square. Okay. So let's say the square. Okay, let's separate this one. This is strain energy or spring energy. Strain energy means potential energy. Okay? Clear? We have two types of energies exist. Potential and kinetic. And then we just spread some parts here, internal parts, and we derived from these parts every very mixed, big bang formulation. Okay, good. Okay, this one. So initially we have m. So let's start from this point. Let's write here. I'm going in this one, okay? What was the formulation of ut? It was depend on the c. Yes. Please remember this formulation. Okay? This one. Okay? Please look at this. Ut is equal to c coefficient cosine omega n t minus phi. Yes? Okay. Let me return again this condition. In this case, so ut is equal to like this, and u dot t will be equal to c omega n. Instead of this one, if I take from this, it should be negative, yes? Or positive?
Yeah.
Sine omega n t minus phi. Okay? If I didn't make a mistake. Minus. It should be minus. Minus. But we wrote here with square, that's why minus is disappeared, okay? So in this case, first formulation will become E S T is equal to 1 over 2 K U T square is equal to 1 over 2 K. Instead of ut, I will put it this one. C square cosine. Okay. Let me write it like this. Cosine omega n t minus phi square. Okay? This one is equal to this one. Okay? And from this one, I derived this one, and it becomes minus c omega n sine omega t minus phi. So I will put, instead of ut, this one. Okay? And then your formulation will become like this. There is a mixing. This one is here, this one is here. Okay? That's why maybe you are confused. Total energy we will derive by that way. E. So this is a K, is a spring. Sorry, why K? This is a strain. And kinetic and strain. So this is a strain energy, this is potential energy. This is kinetic energy is equal to 1 over 2 mu dot square of t. It should be something like this. Okay, if I derive from this formulation, it will become 1 over 2 m c omega n sine omega n t minus phi square. Okay? Okay? Until here, okay, everything? So initially the formulation was like this. I derived from this formulation this one, and from this formulation the square of this one. For instance, k product this one, ut, this k product this one square. Okay, I'm sorry, here should be square. And second one, 1 over 2 m product u dot t square. Okay, do you understand? Everything is become like this, and then we just put all formulation energy E t is equal to, so E k kinetic t plus E s strain t. So let's rewrite everything like this way. Et is equal to k 1 over 2 m c n sine squared sine squared omega n t minus phi. Okay. Okay. Yes. Then we plus 1 over 2 k c squared cosine squared omega n t minus phi. Okay. So now we have k is equal to m omega n squared. Yes? Instead of this one, I have to put this one. If I put this one here, what it will become? It will become like this. Sorry. I will write this as a marker. Okay. K is equal to m omega n squared. Okay? This initially, this is from formulation of omega n was equal to square root of k over m. Yes? Did you remember this formula? We wrote before, yeah? From this formulation, if you find k is equal to omega square, product m. Okay, this is the same, okay? Please remember this formula. We will use this formula now. Instead of k, I will put m omega square. And 1 over 2 m c squared omega n squared sine squared omega n t minus phi plus, instead of k, I will put this one. 1 over 2 m omega n squared c squared cosine squared omega n t minus phi. So, from trigonometry course, if you know, cosine square alpha plus sine square alpha is equal to 1. Yes? Did you remember you're from trigonometry course? This formulation? That's why if we derive this part outside and this part outside, it will become 1 over 2 mc square omega n square product 1. And if I change it, it will become 1 over 2. Instead of m omega square, I will put k. K c square. Okay? Finished. Please copy this one. Sandor aka assalomu alaykum chachoq. Aka darsdaman. Nimaga tinchmisiz? Yo'q, berganim yo'q. Bergan yo'q ular qog'ozni. Xat berish kerak, xat. Tashlab berganmi ularga? Qo'l qo'yib pechat bergan yo'q. Ular tashladi endi bitta narsani. Chiqargan bo'lsa. Okay. Okay? We are not just in hurry. Going home. Starting takeoff, yes. Like a Boeing 777 tower. Please call Boeing 777. I am going to fly to home right now. Someone else? Okay, good. Okay, we have finished it. ET is a constant. It means that ET is never changed or anywhere. Energy never changed and never inverted. And it can change, inverted, but it's constant everywhere. We have a keeping energy, okay? This is a conservation of energy. Okay. In this case, we have a, here in this point, we have a maximum kinetic energy we can reach, okay? The point, the 0 point, maximum kinetic energy we can reach, but the potential energy here is equal to 0. Yes, this is strain energy is a potential energy, okay? In the corners, if I have a, in the peak points, let me say, in amplitude, okay? Okay, let me say, if we have sine wave like this, yes, this is a sine wave, okay? Let me draw it in different way. Can I clean this one? Qancha mehnatda o'chiramiz. Okay. Okay, I don't have two hands, but okay. We have a spring, yes, like this. Please look. Okay. It is moving like this, yes. If I rotate this like this, it's moving like this, yes. Yes, going up, down. This peak point, peak point. This is 0 point, yes. Okay, I will take this one. I will try to write for you in the left hand. Okay. This is a time, okay? Moving time. So, okay, this is going to like this. Now, did you understand what I'm saying? Yes? It's moving like this, but I am rotating like this. And this is during the time, it's going up, down, blah, blah, blah. Okay? This is our motion. Okay. So now, here, in this case, if I have like this, in this case, there is no any potential energy, okay? It's stopping. When it's in action, like this, okay? When it's in action, but there is no potential energy. It's 0, but it's moving. It's so inertia, okay? It's mass and some speed. It has maximum velocity in this point, okay? Initially, maybe, I don't know, there is 0 velocity. I am discussing about these cases, okay? After the starting the process, okay? So here is the maximum speed of velocity, okay? That's why kinetic energy reaches in maximum case, okay? Here we have a velocity becomes 0, so look, it is going up, 0 and going down, 0 going up, 0 and going down, okay? Did you understand? That's why here is velocity 0. Velocity 0 means kinetic energy is equal to 0. Because kinetic energy is equal to velocity. Spring energy is equal to the coefficients, okay? Spring coefficients, okay? Did you understand? So it is reaching the maximum spring energy, because if I put here, the energy is max. If I loosen it, okay, in some point here, maybe this energy of speed is max, or kinetic energy is max. Okay, did you understand this graph? Okay, this graph says about this. Okay, conservation of energy is a differential equation is equal to this one, which we already derived from this formulation. Okay, this one is the same as this one. Conservation energy is ED during the time is equal to 0. So energy do not change. Total energy do not change in our case. That's why this formulation always is the same. Okay. Of course, we have a kinetic potential energy. This is the ideal case. In real case, we have some frictional energy, some heating, blah 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 blah, some action of the air. Okay, we have too many things, which is just influencing our system. Maybe some magnetic energy also. Maybe it can influence, or gravity of the Earth. I don't know. It can also affect our object. Okay. That's why anyway the energy conservation formulation in ideal case is equal to 0. If we try to derive from this formulation, it will become something like this. Okay. Let's write ET during the time energy M U dot square plus 1 over 2 K U square. And now from this one I will try to derive so if I derive from this one, which one is changing during the time? Only speed, yes? That's why speed derivation is equal to 1 over 2, this is comes to here, 2, product M, product derivation of U dot is equal to U dot dot, and negative 1, the power, it becomes U dot itself, okay? Plus 1 over 2, K, again this one, okay, I'm not going to write the K, 2 power it comes here, product K, product U dot, product U, okay? And last is equal to what? 0, yes? This one, this one, this one, this one, we can remove, and this one also we can remove. And what comes here? Mu dot dot plus Ku is equal to 0. Okay? Our final formulation is came again here. We initially saw at the beginning of our lesson, maybe, or the middle of our lesson. So this formulation. Now we came to formulation again. Okay? Now the next case is the viscous damping. For the viscous damping, we need deep breath. Okay? Please have a rest and take some break. And then we can continue viscous damping. Okay? Okay? Please copy everything and you can continue later.